Example 3, M&Ms. You sample 465 M&Ms. The sample had a mean of 0.8635 grams. The population standard deviation is 0.0565 grams. Test the claim that the mean weight is greater than 0.8535 grams and use a significance level of 0.01. So we want to identify the following. N is equal to 465. The sample mean is 0.8635. And the population standard deviation is 0.0565. So the requirements. Well, number one, that the sample is a simple random sample. Number two, the population standard deviation is known. And either or both of these conditions is satisfied. Well, the sample is large because it's 465, which is greater than 30. Or the sample is from a normally distributed population. So therefore, these requirements are met because of the fact that the sample is greater than 30. Now, we want to state the claim and the opposite of the claim. Well, the claim states that the mean weight is greater than 0.8535. So, if we take a look at the claim and look at the opposite of the claim would be less than or equal to 0.8535. So therefore, that equality is going to be located in the null. And therefore, the claim where it's greater than 0.8535 is going to be in the alternative hypothesis. So we can then identify the null in the alternative hypothesis. So the null is that the mean is equal to 0.8535, and the alternative hypothesis is that the mean is greater than 0.8535. Number three, we're going to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Well, this is a right-tailed distribution since the alternative hypothesis contains the equality greater than symbol. And then select the significance level. In the problem, it states the significance level is to be tested at 0.01. And so now we're going to find the test statistic for testing a claim about a mean where the population standard deviation is given. So we know N is equal to 465. The sample mean is 0.8635. The population standard deviation is 0.0565. And the mean is equal to 0.8535, the population mean. So now we're going to plug it into the formula for Z. So we know that the sample mean is 0.8635. We know that the mean in the problem is 0.8535. We know that the population standard deviation is 0.0565. And we know that the sample size is 465. So let's go ahead and do this on our calculator. So we take 0.8635, subtract 0.8535. And we get the following in the numerator. And then we're going to divide that by, we're going to add a parenthesis outside, and then on the inside we're going to put the numerator of 0.0565 and then close that, and then divide that, and then contain this in parentheses. So that's the second square root of 465, and then close that parentheses, and then add another one at the end, and then select enter. And so we end up getting 3.816612. Rounding that to 2 decimal places gives us a test statistic of 3.82. So now what we're going to do is we're going to go ahead and then draw the curve and label, and then use the p-value method and the critical value method. So let's start with the p-value method. So with the p-value, we're going to draw our bell curve. We know that it is our Z test statistic, so we know that the mean is going to be 0. We know it's a right-tailed test, so that means this test statistic is going to be located over here on the right, and we have 3.82. And so what we want to do is we want to find the area to the right of that. So we want to find out what is the p-value there. So we want to determine the p-value. So the p-value is going to be the probability where z is going to be greater than 3.82. So let's go ahead and use StatCrunch to find that p-value. So since it's a z test statistic, we're going to go to Stat, Calculators, and we're going to go to Normal. And therefore, we're now going to say that the mean is 0, standard deviation is 1. We're going to change this to be greater than or equal to, and then we're going to put in 3.82 as our test statistic. And then we're going to go ahead and then copy our p-value here. So the p-value, if we round that to 4 decimal places, is going to be 0.0001. Now, we're going to make a decision using the p-value. Now, we reject the null if the p-value is less than or equal to the significance level. And we fail to reject the null if the p-value is greater than a significance level. Well, since the p-value is 0.0001 is less than 0.01, therefore we're going to reject the null. Okay, now how do we do the critical value method? We want to find the critical value for the significance level of 0.01. Since it is one tail, we want to be able to find the critical value of when alpha is equal to 0.01. So let's go ahead and do that. So for the critical value of 0.01, we know that we're going to take the mean is 0, standard deviation is 1, and we want to make sure it's greater than or equal to, and then we're going to put in the area of 0.01, and that gives us 2.33 for the critical value. So now that we have our critical value, now we can go ahead and then draw our distribution here. So if we draw our distribution, we know that we have a mean of 0, and then we're going to place the critical value over here, which is 2.33. And then we're going to shade the critical region. So this is going to represent the critical region. And so now we're going to look at the test statistic. And the test statistic we found is 3.82. So 3.82 is to the right of this. And so 3.82 is the test statistic. And what do we know about the test statistic? Well, it falls in the critical region. So we reject the null hypothesis if the test statistic is in the critical region, and we fail to reject the null if the test statistic is not in the critical region. And since the test statistic of 3.82 is in the critical region, then we reject the null hypothesis, just as we did with the p-value method. Okay, now let's go back up to the claim. Well, the claim is that it's greater than. So we know the claim is greater than, and we ended up rejecting the null hypothesis. So what that means is, out of these 4 possibilities for our conclusion, we would look at the first one, because the first one, the original claim, does not include the equality, and we rejected the null hypothesis. So we'd say that there is sufficient evidence to support the claim that, followed by the original claim. So we would say the following: there is sufficient evidence to support the claim that the mean weight is greater than 0.8535 grams.